Yeah, that's really tough pieces. It's kind of helpful because the manual has like discussion topics. So great you just talk about all those.
I talked about all my graphs and then wrote a paragraph, and then I realized that the lab manual had discussion topics, so I have to go back and talk about those.
How happened? Start to go to use the lights when left take coordinates or left. Today will be very boring. Nothing exciting for myself, but we should go over some boring stuff, and it's especially boring because you have partially made it in your homeworks, but we need to have it here. We are in PCAM class. We promise everyone to describe outcome of characterization in instruments, but instead we do linear algebra and quantum theory. Right now we are applying our skills in quantum theory to particle in the box, which may model oligomers of conjugated polymers or thin films of semiconductors. There are three sections: eigenstates, eigenenergies, prediction of the future, and multidimensional boxes in 3 dimensions. We are on the first section of eigenstates and eigenenergies, and you already know what are the energies and how orbitals look like, but we need to slowly but surely go once again through where they are coming from. Normalization and stuff. So we are here. There is a homework which I have to send the script that we will practice it today at the lab. This will be fun, and it will be preparation to predict the future. It will be really quick, so probably the quickest step. The second part of homework, which is due next Friday, not coming, but next, it will be a little, it will be again not that based, and I have high expectations that you will like it. It will be exciting. And previous year, mainly in this perspective. So, in order to play fun stuff with quantum theory and with predicting future and outcomes of the measurements of observables, one always, well, most cases, one needs to start from what? From solving which Euler equation? Which is lower level?
Independent.
Yes, so we need to solve independent. If we have a box, it means we can work out of the box. There are infinite walls, and you have size of the box. These kinetic energy. So we always need to write down Hamiltonian because it is what comes to the time dimension equation which we need to solve. Hamiltonian includes kinetic and potential energy. Kinetic is always is one dimension second derivative over position, and potential will be zero, same as in the free space inside the box, and it will be infinite outside of the independent coordinate is smaller than left edge or higher than left edge. So the solution of such problem in some sort is trivial and in some sort special. Trivial that inside the box we have the problem is identical to free space, where the solutions are just plane waves, right? Exponentials with accumulating phases, right? as something moves, it accumulates phases, and something changes. But outside of the box, there is no wave function at all. So this is a standard practice in differential equations, setting up boundary conditions. So at the left and right edges, wave function is mandated to be zero. It's mandated to be zero further away from edges, but we don't care. Edges are sufficient. So it is a reasonable approach to assume that wave function has standard shape, as we always were philosophically discussing. So it is exponential with imaginary power, where in power something linearly accumulates as we progress in space or as we progress in time. Right? So we do not have time, it's time independent, so something progresses in space with some rate t. And the plane wave can go left and right. We do not have any specifics telling where it will go, so we generally assume there is a position of traveling wave going left, traveling wave going right. And we do not know in which proportions they are entering into the solution. Therefore, we have three independents. Coefficient in front of C E plus C plus, coefficient in front of E minus C minus, and unknown rate of accumulating phase, which we call wave vector. Yes?
Is the k going to be equal in both of those?
Yes.
Okay.
Generally, if we want to be ridiculously rigorous, one needs to make summation of plane waves with all possible values of k. Like putting the c sub p e to the power time kz dk. But from the while telling the story, I know the solution, you already know the solution. And you know that it is the shortest way. If you have from this integral, which includes summation of all possible k with positive and negative, those which are symmetric when it is positive and negative, we expect that they will exhibit constructive or destructive interference in a positive sense that will help us to find solutions. So it's kind of, this is more general and this is made up for simplicity based on our, because we're not starting to solve this problem in fact right now. You already are a little exposed to what we perceive. You know that when traveling waves meet each other, they form standing wave. A standing wave will form if they have the same k. So we kind of making a setup to get a standing wave. Well, if we plug in this solution, as we were doing in plane wave, into eigenvalue problem, into time independent Euler equation, we will obtain that energy will be square of this wave vector. We do not know yet which wave vectors are allowed and permitted, but this is kind of standard. We take the just plugging in this functional form into did you watch anyone watched historical movies from eastern part of the world, like Korean or Japanese? Okay, so they were some historical outfit with very crazy sleeves. Therefore, if they write or just tell something, they. That was just. Okay. So generally, the solution is superposition of this stuff, and we are taking help from our best friend Euler, who tells that Hotel's guys do not fear of imaginary exponentials. They always can be replaced to trigonometric sines and cosines, right? So this one is replaced by Euler here, and with negative, we just swap the sign in front. Flip the sign in front of the sign, right? And then we can reorder terms. There are four terms, and we can group them. So cosine goes here and there, and then we have summation of the expansion coefficients, and imaginary sign goes here and there, and then unknown coefficients are subtracted in front. So we do an educated guess for the functional form of the solution. So, and at this point, we already kind of assume that traveling waves are already converted into standing waves, right? With slopes and nodes. We just do not know at which proportion they come. What are these expansion coefficients? So, in order to find unknown wave vector, unknown C plus and unknown C minus, we are plugging in this functional form into generally into the equation that we solved. But right now our equation is like split onto two lines. First is actual Schrodinger equation. Second is just set of boundary conditions, so which we need to match. So we need to select such C plus C minus and K which will match boundary conditions. So boundary conditions, which mean you plug in the z equals 0 or z equal L, the either left or right edges of the box. So if you use your left edge of the box, a sign turns into 1, sign turns into 0, and we request that this stuff is equal to 0. So since this term is 0, we cannot tell anything definite about the subtraction. But since this one is 1, and it needs to be equal, we get an equation for connection between C plus and C minus. This is 0, and this C plus plus C minus equals 0, right? No objection. Which means they are of the same amplitude and opposite sign. Right?
Neg.
Same amplitude, magnitude.
Neg.
Okay, thank you. And opposite sign. Amplitude is not good.
Whatever.
Okay, I don't care. I'm not arguing. So wherever we have C minus, we can replace it by C plus minus C plus, right? So we do not need to follow the two of them. We can use only one of them since they are not independent. Now we need to go to the left and right bound. So we already discarded cosine, right? We already can replace. We probably skipped the step. So it was in front of sine. It was C plus minus C minus. But C. What? And we can replace it to C plus minus C plus minus minus C plus, right? So therefore, this one converts into 2C plus. C plus is unknown expansion coefficients in our equation, and in this context, it's not the name of the programming language. how do we match this equation? So, in fact, I was not intentionally lying, I just forgotten to bring up that we need to satisfy several things. We need to satisfy Schrödinger equation with kinetic energy where from we are getting this oscillating exponentials, first thing. Second, we need to match boundary conditions. And the third, we need to keep sanity of our brains, which means wave functions have to be normalized. If we interpret wave function as a wave function square as probability distribution, and if you have one electron, integral from plus to minus infinity should give one, because you have only one electron. So we will need to match boundary condition first, and second we will need to match the normalization. So sign equals 0 when argument is proportional to pi multiplied by integer number. No objections. So this KL must be integer number. And it gives the, if you divide both sides by left and right by L, it gives the values of K. So this boundary condition will be correct only if wave vector K takes discrete natural numbers multiplied by this factor pi over L. It means if you interpret K as something related to molecular momentum, it means that it is traffic signs permitting only a discrete set of velocities. We cannot continue to accelerate, we can just write with specific values. So we know everything except C plus. So our wave function, which is almost ready, will be this sine K is replaced by pi n over L times independent variable. And then we need to take care of this C plus. Once again, if we plug in the value of K into expression of energy for kinetic energy, and inside the box we have only kinetic energy. This we will see that it will be discrete energies, which values are equal to combination of constants times square of the integer number. So their offset will increase. First they will be dense, and then they will be sparser and sparser. And it's interesting that these energies are inversely proportional to the size of the box. So if you squeeze the box, make it smaller, energies and their offsets become larger. So stay alert if you are watching and prepare to find mistakes. There could be some. So this is almost already a solution. You just need this C plus. And our requirement is the product of these wave functions. Generally, philosophically, it should be from minus infinity to plus infinity. But you know that wherever independent variable z is less than 0 or bigger than L capital, wave function is 0. Therefore, we can skip this integration. We form it only from 0 to L capital. And we mandate that it should be equal 1 because we work only with one element. Right? Total probability that this electron does exist and we have it somewhere is 1. It can be smaller or higher or lower probability at certain places, but total over the whole space it is 1. So we just take this function, conjugate in this function itself, multiply it, and perform this integration. So the sign doesn't have imaginary parts, so we have just twice sine times sine of this argument. And the factor here, once it is with I, and other times due to conjugation, we are putting star here and putting minus I to the front. I times I is -1, minus times minus will be plus. How do you take this integral? You already, I need to distribute back your works, but you already know that the grades are not there. But since you completed the previous homework and got good grades, you have an idea how to take this integral. You will take, right? So integral dz of sine square of some constants using any ideas?
You change CZ to a new variable and then change the system, change the integration to a new variable.
But do you know what is integral of sine square?
No,
And do you need to know?
no, I can probably look it up.
1 minus cosine squared.
Yes, yes. So it's the idea is that we transform everything to very, very basic, simple integrals that everyone can take. So if you would have sine or cosine, we know how to integrate it, right? So why don't we convert the sine square into cosine? Since Bill suggested such equation does exist. And if you do not believe this equation, one can always rederive. I remember that I was tortured in high school to memorize trigonometric equations, and I was not able to memorize them, but I just accepted the fact that they existed. One can always find the right. If you practice Euler equation for e to the power 2 alpha, I 2 alpha. You don't need to write it, it's assumable that as e to the power alpha I alpha times e to the power I alpha, right? And you convert it into Euler at the left and at the right. You get cosine double argument, sine double argument, cosine plus I sine single argument, cosine I sine single argument. And then you open brackets and see that for real part it will be cosine cosine minus sine sine. And here real part will be cosine. And you know the if you add together cosine square plus sine square, it will be equal to, yes. So if you, it's equation of circles, the long circle, it will be equation of circle is very fun. If you subtract these two equations, you get 1 minus cosine double argument equals 2 sine of single argument. Not 2, not 2. Not just 2. So where is this? Therefore, any time we see sign of single arguments square, we can replace it by 1 minus cosine of double argument. And it will be a little easier to take. So, divide both parts by 2. Good. So we are taking this into account. And we can split it onto two integrals. Once we integrate just 1 from 0 to L dz, right? What will be the answer for such integral?
No.
Good, thank you. And second, we need to apply integration to a sign of this double argument. And we can kind of guess what will be the answer graphically right away. So if the black line here is cosine of regular argument, so by going from 0 to L, it covers half period. And if you double argument, it makes the full period. And you need the integrate this purple line, which is likely will be plus here minus there, compensating each other and give 0. So intuitively we expect that the second integral will be 0, but we may want to double check just in case. But if we are naive in a good sense and lazy in a good sense, we can go from here and take the answer. It will be 1 equals 4 c plus times squared times that. But if we are picky, let's double check that this is.
Dimitri,
Yes.
on that last slide, you forgot to divide your 4 up by the constants by 2.
Huh?
The last,
Do I need to divide it or I don't?
oh, because you're multiplying, it's their constants.
I'm a little bit confused. Previous years I didn't divide by 2, and this year I decided that on previous slide you have this divide by 2, and you need to plug it in here. Okay. But then I'm not happy with the answer. I was preparing like last hour before the meeting, so if you find, do we need to divide by 2 or we need to skip it, I would appreciate and assign extra credit to find it. So this divide by 2 is a question. Okay? But I'm very confident in the rest of derivations and conclusions. So do not, I invite you to find little mistakes, but do not doubt main message. Okay. So if you want to take this integral, it's boring to have the complicated independent argument. It would be more reasonable to replace it by a new variable, to replace this argument just by letter y. And then in order to identify the same letter y as our integration variable, we may multiply our integration variable by missing factors, then divide by the inverse of such factor, so that we do not change the expression. And for this operation, our independent variable will be 2 pi natural number divided by n times independent variable. And if we play this game, then our integral will be just integral of cosine y to y, right? And as a penalty for this change of variables, we'll have the inverse of this factor. So L divided by 2 pi. And Alex already put this. The first one, integral of 1 from 0 to L will be L. You can pull the same common factor outside of the brackets. So, what is the integral of cosine? We all know that it will be signed with plus or minus. Integral of cosine. So how do you decide? Positive or negative? Throw a dice or look at some scientific so-called. No, never remember things. It's very dangerous. It may play a game with you. No, and especially if you're challenged to answer some question, better to redirect and try to reconstruct logical connections. Because memory, like closing eyes and trying to flip pages in the memory, doesn't help. You may make mistakes and waste time. So assign graphically. Assign is positive near the 0. And if you integrate, it means area under the curve. So if we start integrate from lower limit is 0, if you start integrating, initially it is not start with 0. And then as we go forward to count for this area, it will grow. Right? Grow to mean. And then we know that it is a sign. But definitely the result of integration near 0 and in positive side will be positive. It's plus sign minus. And then we need values of this y, of this new variable y at the upper and lower limit. So when x equals 0, y equals 0, and if x equals L, we cancel our y variable was z divided by L. And if z equals L, it cancels, and we have y at the upper limit is 2 pi n. And then our integral results into this. So the factor L traveled outside of the bracket. Here is the remaining piece of the integration factor, and here is the result of integration at the upper limit and lower limit, which we need to subtract. Okay. At lower, it is sine of 0, which is 0. At upper, it's sine of 2 pi n, which is 0. Good. So we do not have this term. So we have just L. 1. And I'm curious if divided by 2 should be kept here. Last years I didn't have it and I was happy. Okay, so we mandate that norm must be equal to 1 because we have one electron with probability 100%. So we divide the product of this expansion coefficients by 4L, and one curious, we'll check that. And then we can bring a new variable, which will be imaginary unit times real constant C. Then this product of conjugated coefficient itself will be just C squared. Here I'm in doubt. 1 or 2. And then we take square root, which will be 1 divided by 2L. And if you bring back this change of variables, it will be imaginary unit divided by square root of L. So our original trial function was sine with discrete accumulation factor in front of independent variable with unknown C plus expansion coefficient. Now we do know value of this expansion coefficient. It is imaginary and it is inversely proportional to the square root of the size of the box. So if you plug it in, the I times I will be -1, and minus with another minus will cancel each other. So the factors 2 should cancel here, and then the wave function itself will be square root of 1 over L times this sign. Objections? Protests? Suggestions of any found errors? If you don't find it right now, but find it later, please email. I would appreciate it. So, I was borrowing time from you many times, but now I'm giving you 13 minutes back. Meeting is done. Wave function is sine of pi n divided by L multiplied by z with factor 1 over square root of L, and energies are just quadratic. The next thing to do will be predicting the future, practicing combinations of these wave functions with time accumulating things, match initial condition, and see how it propagates forward in time.
So did you not divide it by 2 because when you get to the final wave function, it makes the factors cancel out instead of having to have a 4 divided by the square root of 2?
If I keep this divided by 2, it will be 1 square root of 1 divided by 2L. And if I follow this,
yeah, and that's a little harder to work with.
it's not harder. I just need to double check in peace later. But I don't know. Maybe I don't know who maybe you, maybe I, who has more free time to see the piece and check things. Maybe you have less free time because of I know that some people take like up to 19 credits per semester, which is a killer. Hope it's no one of you that you stay to a smaller number. So meeting is dismissed. Looking forward to see you Wednesday night, 5 p.m. TVV 130.
Why so many?
Same credit this semester, 11.